Uh, Thank you. I hope you can hear me clearly. It's a pleasure to be with you. I came down from Boston today, and I've been looking forward to this weekend for some time. And the title of the talk that I've offered today, by the way, those of you who write at the back will have trouble seeing some of the visual aids that I have. If you'd like to come nearer the front, that'll help. But it's not really an eye exam, but you might find it's that way. My title is Religion Relegated, ? So if you're relegated, that means that you're kind of demoted from, let's say, the big leagues to the minor leagues. And so the question that I have in mind is it the case that religion has been relegated by the advent of modern science? Or to put it more starkly, does science rule out faith? And I want to encourage you, as I give this talk, there are almost certainly going to be questions that arise in your mind. I want you to think of what those are and be prepared to give voice to them and ask me questions at the end, because I've given so many of these talks that I find the most interesting and exciting time for me is when people ask me questions. So I'm going to leave plenty of time at the end for questions, and I want to encourage you to ask those questions. So I've set myself the task of trying to set the scene for this weekend workshop on science and faith. And one place to start, of course, would be to ask ourselves the question, what do we mean by science? Actually, this is a tremendously important question, because if we don't ask ourselves that question and answer it clearly, we may find that we're sort of going to be talking across each other. We'll be going to be confused because we'll be talking about different things. The word science in English comes originally from the Latin word scientia. And of course, up until about the 17th century, all of scholarship was done in Latin. And so scientia was what people spoke about. And in those days, its meaning, the meaning of the Latin word scientia, was simply knowledge. So scientia referred in those days to all the knowledge there is. And even after the scientific revolution, that usage still existed. So for example, in the 18th century, people would refer to science in English or science in French, and they would be thinking of more general knowledge than we think of today when we're thinking about science. For example, this picture, which you undoubtedly aren't able to see, is the frontispiece of the enormous encyclopedia, the Encyclopédie, published in French in the middle of the 18th century. And it talked about the whole of knowledge, but its focus was on technical knowledge. So even in those days, people would speak as if science was all of knowledge, but they would often be really aiming to talk about technical and scientific knowledge, the knowledge that comes from natural science. In the 19th century, a historian such as Macaulay would use the word science just to mean something which is approximately the growth of the human mind. Or even in the 20th century, the well-known philosopher Collingwood called science any body of systematic or orderly thinking. So that's one way to use the word science, and it's historically what people have tended to call it over the centuries. But the modern meaning of science that's been extant for probably the past 100 years or more is different. Those historic uses of the word science to mean all of knowledge or some systematic knowledge, they are not what we mean by science today. So we mean today what used to be called natural philosophy, the study of nature. It's the modern science that we inherit from the scientific revolution, which took place, in the 1600s. And that's the way I'm going to use the word science in this discussion this weekend. Because if we talk about science and religion, then we're not really talking about reconciling, let's say, the gods and goddesses of ancient Greece with, let's say, political theory. What we're talking about is the compatibility of a major religion, of Christianity in this context, with a modern understanding of physics and cosmology and biology and physiology and geology and so forth. And science and religious faith is a burning issue, an important issue in our society, precisely because natural science has gained enormous prestige in terms of its knowledge because of its growth and its success, and because of the technology that it has spawned. So, let's be clear. If science meant just any kind of systematic, contemplative, systematic knowledge, as it once did, as scientia once did, then it would still be the case that theology is a science. Maybe today it wouldn't be the queen of the sciences, as it was once thought of, but it would still be a science. But today, that's not what we mean. And therefore, in my understanding, theology is not a science. It's not something that operates like natural science. Okay, so what is science? One way to think of it is to say, well, science is the study of nature. It's true, but it's, in a certain sense, an inadequate definition. Actually, the problem with trying to define science as being the study of nature is that we don't actually have a clear understanding of what we mean by nature. Now, maybe I was chatting to someone who were telling me that they'd been farming for the past 30-something years earlier, and perhaps many of you work in jobs that are associated with being out in nature in a certain sense. But of course, in the context of natural science, we don't just mean the things that happen in farms and stuff like that. So nature is actually a rather unclear concept, and its ambiguity has been recognized for centuries, actually. This character here on the slide is Robert Boyle. He was, you've probably heard of Boyle's Law. It's one of the most famous laws that you learn early on if you do physics and chemistry. And he was one of the founders of the Royal Society, which was the first nationwide society for science in the English-speaking world. And he was he was a Christian, but he was also a philosopher as well as a scientist, and he actually wrote a whole book which was called A Free Inquiry into the Vulgarly Received Notion of Nature. They loved these great rolling titles in books in those days, right? And so he was actually trying to understand what we mean by nature, and he actually listed 8 different meanings of the word nature in his day. And it's still the case that today the word nature is used for lots of different things. But the meaning of nature that he was advocating in the context of science was what he called the settled course of things, or the normal course of things. So the problem is, we can't just say science is the study of nature, because it's not all that clear what nature is. So actually, science is best understood. It's best way of understanding what science is to think not in terms of its topics, but in terms of its methods. And that's what I think ultimately decides what science is. And actually, in the end, it's nearer the case that nature is what science studies than to say science is the study of nature. But I'll get to that. I want to introduce one other word and try to explain what I mean by it. And that is a word very like science, but it's not science, it's scientism. Scientism is approximately the belief that science, natural science, is all of the true knowledge there is. And it's a philosophical viewpoint that is extremely widespread in our Western world today. And it's particularly important in the context of discussing science and religion because it's an attitude, an outlook, which underpins many of the criticisms of the Christian faith, religious faith generally, that are leveled by the people who are called new atheists. So Richard Dawkins, for example, in his well-known book, The God Delusion, which was published in 2006, in many cases makes statements like this: the existence of God is a scientific hypothesis like any other. So think about that. The existence of God is a scientific hypothesis like any other. I mean, of all the hypotheses that you might think of, the existence of God seems to me one of the most obvious things that actually is not a scientific question. It's a religious question. It's a theological question. It's not a scientific question. And yet, Dawkins, in his critique of religion generally, is making the claim that it is a scientific hypothesis like any other, because he's assuming that any real knowledge is found using the methods of science. Or this other example I'm offering you, Paul Thagard's book, The Brain and the Meaning of Life. He says, what is reality? Those things and processes identified by well-established fields of science using theories backed by evidence drawn from systematic observations and experiments. So he's defining reality as being what is discovered by science. Scientism is rarely explicitly acknowledged. Neither of these two guys really acknowledge it explicitly. But here's an example of someone who acknowledges it very explicitly. This is a character called Alex Rosenberg. He's a philosopher at Duke University. And that's appropriate because science is not something that proves scientism. The idea that science is all the real knowledge there is not proved. It's not a finding of science. It's a philosophical and metaphysical viewpoint, and I'm going to argue that it's a kind of religion in a certain sense. But Alex Rosenberg is a good example of this. He writes in his book, The Atheist's Guide to Reality, scientism is the conviction that the methods of science are the only reliable ways to secure knowledge of anything. And then he says science provides all the significant truths about reality. And in case you didn't quite get it, he goes on to say, once you adopt science, you'll also be able to cease treating the humanities as knowledge. What a remarkable claim. So I've introduced that because I want to contrast scientism and science. But back to giving you an understanding of what science, natural science, is really about. I think many of us have a good sort of general understanding of the strategies that science uses to gain its knowledge. So it relies upon observation, experiment, measurement, systematization, mathematization, self-consistency, universality, and so forth. And I think that these kinds of characteristics are most helpfully summarized under two main headings. And I offer you this as the clearest way of understanding what natural science is really about. And that is that natural science insists upon reproducibility, repeatable experiments or observations. And secondly, that it relies upon what I'm going to call clarity. That is unambiguous descriptions. That especially depends upon measurements, often mathematics or classification and various other types of things. And these two characteristics of natural science mean that its scope is limited. Let me expand these a little bit. First, let's talk about reproducibility. This is a woodcut of Michael Faraday in his lab in the Royal Institution in London. Michael Faraday was probably the most famous experimentalist in the first half of the 19th century. He's got more than it's about five, or somewhere between 5 to 7, depending on how you count it, phenomena or laws that are named after him. And he was perhaps the most widely respected scientist of that era. He's also a fascinating character. He had very little education, so he'd left school when he was 13, and he learned most of what he learned formally in his education by reading books at a book bounders. Anyway, Michael Faraday insisted upon experiment. He said, facts were important to me and saved me. Without experiment, I am nothing. And it was said of Michael Faraday that as soon as he heard or read about some new discovery in those heady days of the 19th century when people were just learning about electricity and magnetism and all the things that we take for granted today, the first thing that he would do when he heard about it is he would go straight down to his own lab and he would try to reproduce the findings of experiments that he'd heard about elsewhere. Because he knew in his bones that science depends upon reproducibility, that if someone does an experiment somewhere and gets a certain result, that someone else at some other time, in some other place, if they pay attention to the details, can get the same result. That's what we mean by an experiment and it's what we depend on in science. So did that make Michael Faraday into an arch skeptic? Far from it. He was actually a lifelong Sandemanian, a Christian of an unorthodox, admittedly unorthodox by the standards of the age, Christian branch, but actually not all that terribly unorthodox by today's standards. He was certainly counted as an evangelical by today's standards, and he was actually the elder of his congregation, which in the Sandemanian church meant that he was actually the pastor. So he would actually preach at the evening and morning services, and he would visit the sick and so forth for substantial parts of his life. So reproducibility was vital to him. Here's another example of reproducibility. I have, for most of my career, studied the challenge of nuclear fusion energy. That is, how do we bring the energy source of the sun and stars, which are reactions of a type called fusion, down to Earth and make the energy available for humankind. Still a ways to go in that research, but ask me later if you want to talk about that. But in 1989, I was working in my lab, and I got a phone call from CBS News, and they asked me whether I would appear on the evening news and talk about cold fusion. And I said, well, cold fusion, what's that? So it transpires that two electrochemists from the University of Utah were claiming that they had managed to make fusion reactions take place not at the temperatures of the stars, which is what we have been trying to do for many decades, but at room temperature. And that was called cold fusion. Well, I went on the evening news, CBS evening news, and I spent a lot of time expressing my skepticism about this. But actually, I then said at some stage during the interview that, well, we wait with interest to hear more details about this. Of course, that's exactly the phrase they captured and put on the evening news, because they wanted to make a story that was really lively and seemed to say, wow, this is really exciting. Well, it took us about 2 weeks to realize that the results were based on a mistake. It took more like 2 or 3 months for the scientific community to become convinced that it was a mistake. And the reason is because thousands of people around the world attempted to reproduce the results that Pons and Fleischmann reported. And although there were some reports of, yes, peculiar releases of energy and so forth, in the end, it could not be reproduced in a way that was convincing from a scientific point of view. And that's how science works. If we aren't able to reproduce it, we aren't going to take it seriously as a claim in science. Now, you might say, okay, well, I'm not quite sure whether I believe this, because let's think about astronomy. After all, if reproducibility is important, you can't do experiments on the stars, they're too far away, and yet isn't astronomy a perfectly good natural science? And yes, it is. But it's not the case that astronomy doesn't depend on reproducibility. It actually does depend upon reproducibility. It depends upon the reproducible motions of the stars that we can make sense of when we examine the night sky. Or even something as unusual as what Chinese astronomers saw on the 4th of July, 1054, when a bright new star, brighter even than the morning star, grew brighter and brighter over several weeks in the sky and then gradually faded away. That was, in a certain sense, maybe a unique event, but actually, one can do reproducible observations about that of an event like that. That event was a supernova, by the way. It was a star blowing up far away from the Earth. And the reason is this. First of all, that wasn't the only supernova that's ever happened. In fact, these days, astronomers have good enough telescopes that we can see supernovae happening on a pretty regular basis throughout the sky. Secondly, there were reproducible traces left from that supernova. And in fact, this is a photograph of those reproducible traces, and it's called the Crab Nebula. It's actually the debris from that stellar explosion expanding rapidly in time. And anyone with a halfway decent telescope can look up into the night sky, reproducibly see the Crab Nebula. There are actually also many reproducible phenomena associated with it. So, for example, in the middle of that nebula, there is a pulsar. That's a star emitting radio waves that are pulses on a very regular basis, reproducible phenomena. And actually, some students at Dartmouth University, undergraduate students at Dartmouth, took the record of the photographs of the Crab Nebula over a couple of decades, and were able to show that the Crab Nebula is still expanding, and that if you were to reverse the velocity of the Crab Nebula and run the movie backwards and ask when did it finally, when was it all together in one place, the answer turns out to be the middle of the 11th century, which is fully consistent with the fact that it was observed by Chinese astronomers. So these are examples of the way we rely upon reproducibility, even in the observational sciences like astronomy. So reproducibility doesn't just mean simplistic reproducibility at will. But there are many things that are involved in our lives and give rise to knowledge which are not reproducible. And I think the most helpful example I can think of is human history. So the activities of historians in general benefit only to a very minor extent from anything that comes from the natural sciences. So, for example, how do we know the truth of the statement that Julius Caesar was assassinated by fellow senators, on the Ides of March 44 BC? Not by reproducibility, because it's a unique event. Not by experiment, not by any kind of evidence like that of the natural sciences. And yet, history is real knowledge. It's just not scientific knowledge. So, scientism is a terrible mistake. And reproducibility is one of the things which emphasizes how much of a mistake it really is. Because many things in our lives don't possess reproducibility. Whole disciplines are of a different character from the sciences. Things like language, literature, philosophy, jurisprudence, sociology. All of those disciplines work in different ways. They have different ways of developing their knowledge. And it's perfectly good knowledge. It's important knowledge. It's just not knowledge like the sciences. Economics is an interesting case because economics actually is often very, very mathematical. So the economists are often, trained in mathematics, and they do mathematics just almost as much as sort of theoretical physicists do. And yet, economics is not a discipline that lends itself to reproducibility because you can't do an experiment that's reproducible, on a whole nation's economy. When I was living in England in the time when Margaret Thatcher was the prime minister, and Milton Friedman, who was a famous American economist, who had what were called monetarist principles, was very influential with Margaret Thatcher. In fact, she implemented a lot of his economic principles on the British economy of that time. And just think, if that's the nearest thing you're ever likely to get to an experiment that an economist can do on a whole economy and see whether his theories are right. So you could ask yourself the question, does that mean we now know whether the monetarist theories of Milton Friedman are true or not? Of course it doesn't mean that, because it wasn't a scientific kind of experiment. It wasn't something that you could do reproducibility, try it on this economy, do it on this other economy over there, and another economy over there. It's out of the question. And when we think about politics, for example, this politics is something which is often misleadingly called political science in the academy. Of course, when people refer to political science, they're harking back to that old-fashioned meaning of scientia. They're not saying it's really like natural sciences, because actually consistency and predictability and reproducibility, which is what natural science is the exact opposite of what seems to go on in trying to understand politics, which is all based largely on pragmatism, public opinion, and all kinds of other things that are not scientific. So all of these types of disciplines are not sciences in the sense that I mean. Now, it is true to say that some of my colleagues, even at a place like MIT, bristle when I say that these disciplines are not sciences. But I argue that they shouldn't bristle. They bristle because they assume that I'm belittling their disciplines by saying that they're not scientific. But I'm not, because I don't subscribe to scientism. I don't think science is all the real knowledge there is. I think these disciplines are very important, and they're things which we should study very carefully, and they have serious, thoughtful, deep, and systematic studies applied to them. But scientism remains a very strong influence in the academy today, as it has done for the past 100 years or more. Let me move on and say a little bit about this idea of clarity. I'm using this in a kind of technical term. So it's really what we require in order to be able to express and communicate the results of a scientific experiment or observation and know whether it is in fact achieving the kind of reproducibility that the natural sciences depend upon. So the results of any scientific explanation have to be expressed in these unambiguous terms. Otherwise, we can't tell whether we got reproducible results or not. And so this clarity involves things like measurement. This little photograph is a photograph of the standard kilogram, which up until extremely recently, the last couple of years, was the standard of measurement of mass. So all masses were measured by reference to the standard kilogram. In the last couple of years, there has in science been an important transition, and we now define all of our standard scientific measurements, mass, length, time, etc., on the basis of physical phenomena rather than artifacts. But this was the artifact that was used for a long time. But it's a way of reminding ourselves that one of the things that science does very importantly is do careful measurements. So measurements are a way of getting this clarity. Mathematics is also very important. It's an ideal, in a certain sense, of the physical sciences, but there are other ways in which clarity is approached. For example, in botany, there's lots of field work that one has to do when one is discovering different types of plants. And that field work is carefully regulated and carefully studied and implemented in such a way to give clarity. For example, in physiology, the way that we describe animal or human bodies, that clarity is also very important, even though it isn't necessarily mathematical. But many things in our lives and in our world lack that kind of clarity that is insisted upon by the natural sciences. So here are some examples: the beauty of a sunset, the justice of a verdict, the drama of a play, the significance of a history, the love of a woman. These are things which are very important to us. But none of them can, in a certain sense, be given the kind of clarity that is required by science. I don't mean to say that science can't study these things. If you take, for example, the sunset, Science can indeed study what goes on during the sunset. It can explain why there's a gradation of color down the sky because of the refraction of the sun's rays, because of their scattering of dust particles or water particles, or just atoms and molecules, so that science has a way of describing what is going on during the sunset. But when it has finished its description, it's finished its analysis, it's missed the point. Because the point was not the sunset, physical description, it was what's beautiful about a sunset. And it's the same with these other types of things. So, I've been talking rather a lot, and I wanted to pause and give us a little time to think. So I want to illustrate this issue of whether clarity supported by reductionism really makes sense by a little clip. It doesn't last very long. It's going to, with luck, if the sound music works, it's going to be quite loud. So let's try it. So the question is, what is this event? So if we want to have a scientific description of this event, focusing on the young lady, she has two pieces of alloy made of copper and zinc and various other things. She brings them together. The electrons in the surfaces of those copper plates interact with one another. They transfer momentum to the lattice of the ions, and vibrations are sent through that alloy. Those vibrations couple to the air around it and make compressional waves, which then propagate out into this large space. That's the scientific description of what's happening. It's perfectly correct. I didn't mean to make any errors in my description, but it misses the point. Of course, this young lady is much more than that. She's part of a symphony orchestra. So is the character behind with what seems to be a hammer. This is, by the way, the famous hammer blow from Mahler's Sixth Symphony. Those of you who are classical music buffs may know that. But the point is that person, those people, are part of a much bigger entity, the symphony orchestra. And the symphony orchestra is part of something much bigger, which is, the entire concert with its audience and the hall and so forth. And what's more, what is happening is music. It's not just vibrations. And indeed, that music has deep meaning for the audience. But music's meanings aren't present in that scientific description that I just gave you in isolation. Music only has meaning when it's elicited by the very act of hearing, by the connection of the music to the human. And so, in a certain sense, those things, all of those connections, obviously don't possess the kind of clarity of being able to be expressed unambiguously in ways that can be conveyed by scientific terminology. So, finally, just talking about science, I want to draw out one additional important factor which arises from this insistence on reproducibility and clarity. And it is that purpose is deliberately ruled out in scientific descriptions. So this character here is Jacques Monod. He was a Nobel Prize winner in medicine. And he wrote a book called Chance and Necessity. And he said in this book the following quote, which I like. "The cornerstone of the scientific method is the postulate that nature is objective, in other words, the systematic denial that true knowledge can be got at by interpreting phenomena in terms of final causes, that is to say, of purpose." Now, I like this quote, first of all, because the beginning of it is a wonderful example of scientism. So if you look carefully at the first sentence, you see he's talking about the scientific method, okay? And then the second sentence, he's saying the systematic denial that true knowledge can be got at. So he's equating science and true knowledge. So in a subtle way, he's basically practicing this outlook of scientism, the belief that science is all the true knowledge there really is. So that's a critique of his statement. But I think that the other reason that I like this statement is that I think it's actually true as a characterization not of all knowledge, but of science. It's true that by its insistence upon reproducibility and clarity, modern natural science rules out personality and purpose as part of its description, really sort of on principle. In fact, that's what makes modern science different from Aristotelian science, or the science that came before the scientific revolution. And if that is what science is, as I assert it is, then there can never be a scientific description of personality, of agency, of purpose. We're going to have to look for that in non-scientific terms. Now, actually, in the last, let's say, quarter of the 20th century and extending up till today, there has been within the academy, within universities in the West, a reaction against scientism. And that a part of that reaction is part of what is called postmodernism. Postmodernism is a fashion, a trend of thought, mostly in philosophy and literature and the humanities, that has become very powerful and very predominant throughout the academy. But an important part of that, not all of it, but an important part of it, is a repudiation of scientism. So this character, whose photograph I'm showing you, is called Jean-François Lyotard. He's one of the icons of the postmodern movement. And at the end of the 1970s, he wrote the following: "Scientific knowledge does not represent the totality of knowledge. It has always existed in addition to and in competition and conflict with another kind of knowledge, which I'll call narrative." Or in another place in this book, he says more simply, knowledge is not the same as science. Straightforward. So this is a repudiation, a denial, an argument against scientism. And so it's true that many academics in the non-scientific disciplines join in this rejection of scientism. And I would argue they do it rightly. They're right to reject scientism, because scientism is pretending to a monopoly of knowledge that is not valid. Unfortunately, however, in the postmodern movement, very often this is taken to such extremes that the critics, like Lyotard, end up denying to science its own expertise in the area of the study of the reproducible behavior of the universe, in other words, of nature. And that provokes all kinds of arguments, because scientists then get up in arms and say, no, science is really important. And then the others say, no, science is not all of real knowledge. So the danger here is that in postmodern, very often, the baby is thrown out with the bathwater. The baby science is thrown out with the bathwater scientism. But that's not necessary, provided we draw a distinction between science and scientism. And that is important in this discussion, and I've taken a while to get round to saying this. The reason I'm spending so much time on this is that Christians often confuse science and scientism. That's understandable, because often atheists, like Richard Dawkins, for example, put forward arguments against God and religion that they claim are science, but are really scientism. They rest on scientism. But if you're not alert to this, you might feel threatened by those kinds of statements. So Christians, actually, of all theological opinions, are often confused by this. On the evangelical side, evangelicals often reject science because they feel, in a certain sense, threatened by the scientism, which is understandable. On the more liberal theological side, folks often incorporate scientific presumptions into the way they understand their faith or the Bible or whatever it might be. But in both cases, both sides of the theological spectrum are often misled because they're failing to distinguish science from scientism. So I think that the most important thing that will help us as followers of Christ to understand the relationship between science and Christianity is to distinguish between science and scientism. this is not always easy. It's not always easy, particularly when you're not a scientist. It's very hard to tell what is real science and what is just some kind of presumption on the part of the critics. So I'm not claiming that it's easy, but I do think it's of the first importance in a proper understanding of the relationship of science and Christianity. Having said all of that, having said that there is important knowledge in other disciplines, that scientism is a ghastly intellectual error and so forth, I think nevertheless, maybe you're out there and you're thinking, and I'm sure there are people who are thinking, well, still, isn't science better knowledge than, I don't know, history or politics or sociology? And isn't there actually an even more stark contrast with theology? Because science seems to be remarkably successful at generating consensus within the experts about the truth of particular questions. Whereas in theology, disputes seem to be interminable. I agree, actually. Science is very good at producing consensus and practical knowledge, and that's one of the reasons why I'm a scientist. But I think the question is about whether it's better knowledge. I'm not so sure about that. I mean, maybe it's better knowledge in some sense than politics or literature or sociology or ethics. But I think one of the reasons why science is so successful in its knowledge is because it's chosen to answer the easy questions. This might seem a bit surprising to you. I mean, obviously, lots of people find science very intimidating, all those little mathematics, and golly, I don't understand anything about that. But really, if we can rely on reproducibility and clarity, those are the easy questions. The hard questions are the things that aren't necessarily reproducible and aren't necessarily clear and unambiguous. And those are just as important questions as the questions that science studies. These two illustrative points about the complexities and difficulties of answering political questions are from an earlier era, deliberately so that I don't provoke sensitivities in the current political climate. Now, just a few closing thoughts. First of all, one approach to resolving the question of the relationship between science and the Christian faith is to put forward the idea that they are totally separate and they're never talking about the same thing. So Stephen Jay Gould coined the acronym NOMA to stand for non-overlapping magisteria. What that means is this idea about science and faith. Quote, "Science tries to document the factual character of the natural world and to develop theories that coordinate and explain these facts. Religion, on the other hand, operates in the equally important, but utterly different, realm of human purposes, meanings, and values, subjects that the factual domain of science might illuminate, but can never resolve." So he thinks there can't be an argument between religion and science because basically they're talking about totally different things. That's the argument. But I think that this approach is inadequate, and I don't agree with him, and I don't adopt this viewpoint. Just in brief, the argument is not, I'm saying, is not between science and religion. It's between scientism and all the other non-intellectual disciplines. And it's that argument which is polluting the discussion of science and faith in our society today. And NOMA misses that wide scope. It's not just science versus religion. It's scientism versus all other ways of thinking about the world. Actually, the second thing is, and I'll expand on this in just a moment, science and religion actually do overlap. What's more, the idea of non-overlapping magisteria leaves no room for kind of foundational or confessional historic faith. In other words, Christians think they're talking about facts when they talk about the resurrection of Jesus. Well, what Stephen Gould has said is, no, religion isn't about facts. Well, I think religion is about facts, okay? So I think that NOMA doesn't leave room for that. And finally, It turns out no one actually likes Noma, because the atheists think this is a sop being thrown to the religious people, that we're sort of getting them off the hook. We're letting them off the hook. And the religious people likewise don't like it, because they don't want to be thrown a sop. They want to be paid attention to. So in contrast, I want to talk about the fact that science and the Christian faith do overlap a lot. In the first place, and I'm not going to unpack this right now, theological and religious viewpoints were extremely important in the development of modern science. For example, the idea of laws of nature came from the idea of there being a divine lawgiver. So theology was part of, in a certain sense, the development of the ideas of laws of nature. The idea that it's important to go out and do experiments because practical applications of our knowledge of the world are important for Christian charity's sake, as Francis Bacon actually literally put it, for the relief of man's estate. That was an important impetus to experimental science. And in fact, what happened was that science, as we now know it today, got going in the fertile cultural and theological and philosophical matrix of biblical theism. And it didn't get going in a lot of other places. And so the theology was an important part of what gave rise to natural science as we know it. That's one side. The other side is, think about the relationship between science and theology. Theology derived some of its vision of God in part from nature. You can think about the Old Testament, you can think about the Psalms, you can think about the book of Job. These are places where voice is given to the awe and wonder and the extent to which we discover about God through nature. Or in the New Testament, St. Paul says in Romans, what can be known about God is plain to them because God has shown it to them. Ever since the creation of the world, his invisible nature, namely his eternal power and deity, has been clearly perceived in the things that have been made. So Paul is saying you can approach God, you can understand some things, it's actually the impersonal characteristics of God that he's referring to, by looking at nature. And indeed, awe at the transcendent and inexplicable comprehensibility of nature leads even secular scientists, for example, Einstein and others, to speak in theological terms very often. So scientists are not inherently atheological. On the contrary, secular scientists get to pantheism at least, mostly, and they perhaps decline to go further. But most of the scientists who were part of the scientific revolution went a lot further than that because many of them were Christians. So that's one aspect of the overlap between science and religion. Another is this, that religious beliefs about nature are rightly constrained by science. So here's a picture of Copernicus. Copernicus was the guy who told us, or first proposed, that actually the Earth orbits the sun rather than the sun orbiting the Earth. Well, Copernicus was right. And Galileo had a big argument with the Roman Church because he agreed with Copernicus. And this is a very famous event in the history of science, and it's often pointed to as being an example of the way that the church was being held back in its scientific views by theological conservatism. Actually, it was a lot more complicated than that, but I won't go into it. But still, the church, those people in the church who advocated that no, it couldn't be true that the earth revolves about the sun, because in Psalm 104 it says the earth is firmly established and can never be moved. They were misinterpreting their faith. And so actually science helped to improve their interpretation of their faith. And so there are things, religious beliefs about nature, which are constrained by science. And natural science is sometimes constrained by religious principles. If you're in any kind of research organization, university, on something like this, and you're doing experiments on human subjects, there are all kinds of rules and laws that you are obliged by federal law to abide by in order to do that, because you're being constrained by ethics. And ethics, after all, is largely based on religious viewpoints. So there are many examples of other types of ethical principles which come up in science. So the bottom line is natural science and religious belief are not non-overlapping. They mutually constrain and correct one another. But that doesn't mean that science rules out spiritual significance. And then I want to come to the second, let's say, main important principle in understanding the relationship between faith and science. And that is to recognize that we can have complementary descriptions of phenomena or perspectives on phenomena. These are in fact necessary to describe and understand many aspects of the world. I gave you an example from the woman crashing those things together. But actually that's true in science too. And one way to illustrate it is to think about the human person. So you could say, truthfully, from a scientific perspective, that I am an assembly of quarks, leptons, gluons, and photons. Those are elementary particles. You could also say that I'm a combination of elements, atoms and molecules. You could say that I'm a set of cooperating biological cells guided by DNA and RNA. You could say, truthfully, that I'm a biochemical machine powered by bioenergy, that I'm an animal, a purposeful mammal with warm blood and hair, that I'm a human with consciousness, intelligence, maybe some intelligence, that I'm a husband, a lover, a father, a teacher, a sinner saved by grace, an immortal spirit loved by God. And all of these descriptions at different levels or in different perspectives can simultaneously be true. None of them rules out the others once we set aside the kinds of reductionistic and scientific viewpoints that are altogether too prevalent in our society today. Those complementary descriptions can simultaneously be true. And this is the number 2 principle for helping us to understand the science and religion relationship. Well, I want to finish today, and then we'll move on to questions, by giving a contrast. And the contrast I want to give is between what I take to be the predominant secular view of our society today in the West with a Christian understanding. I think it's fair to say that the predominant secular view, at least in the intellectual West today, is that there is no reality beyond what is discovered by science, and there is no moral authority or good higher than the freedom of the individual. Now, both science and individual freedom are good. But Christians like me have a different perspective. We believe that both the deepest reality and the highest moral authority or good are to be found in loving relationships. We believe that the universe exists because a God whose nature is love, expressed in relationships, has made it and loves it. And we believe that individuals find their true fulfillment in entering willingly into a loving relationship with God and with one another. Now, we can see as we look around the world that all is not love. There's a great deal of suffering, alienation, anger, strife, and war. But we believe that God has entered into the experience of his creatures in the person of a human, Jesus Christ, and taken upon himself that alienation and suffering, and at great cost overcome it. And we believe that this happened in history and was witnessed by the entire population of a city, and that it echoes up and down the centuries still. And so, is religion relegated? No. My Christian faith is, I believe, compatible with science. It's enriched my career. It's made me a better scientist. And like many scientific figures throughout history, I think science leads me to God. And I think that Christianity and science are complementary, both in knowledge and in life. But I think Christianity is incompatible with scientism, and the reason is basically because scientism is a rival worldview, or one could almost say a rival religion. Thank you very much for listening.
Dr. Hutchinson, we're grateful to you, and maybe I can say on behalf of the theologians in the room, we're grateful that you think our questions are harder than yours.
They certainly are.
So we have time for question and answer. We have a couple of microphones that can rove around the room. Flip, you're going to help me with that, I think, and the gentleman next to you can get us kicked off. How about that?
Thank you. That was a great presentation. There is at least one aspect of science that some people say refutes scientism, and that is quantum mechanics. There's a book that was written called The Quantum Enigma that talks about consciousness. I'd love your thoughts about that. The other question is, what do you say to people who say, well, we can't explain beauty via science now, or our sense of justice, but eventually we'll get there? How do you answer that question?
Yeah, okay, so we've got two questions on the table. First of all, quantum mechanics. I won't spend too much time on that. The quantum description of the world is a description in which we solve equations, but those equations describe, instead of what is actually happening, the velocities or the positions of particles and stuff like that, those equations solve for the wave function, which is something which expresses the probability of things happening, as opposed to the actuality of things happening. And as a result, we have something called Heisenberg's uncertainty principle, which means that it's actually not possible to solve all the equations and predict the future absolutely. And I think most physicists and scientists generally regard that as an important development. It's certainly it was a historical watershed in the 1920s when it came about. I'm not sure that it disproves scientism. What I think it does bear upon is that it bears upon the problem of whether the world is deterministic or not. Determinism means, can I solve the equations of motion of all the particles in the universe and therefore predict the future? If the future is perfectly determined by the initial conditions, then surely everything is determined ahead of time, and so there can't be anything like free will. There can't be God acting in the world because it's all determined by the equations of science. I think quantum mechanics sets that aside and greatly weakens any belief that one might have in determinism. I'm not sure it solves scientism per se, but we could come back to that perhaps another time. What was the second question? The second question was...
Will science eventually be able to describe justice, beauty, things like that?
Am I just talking about the weakness of science that eventually will move forward? Obviously, we have seen tremendous developments over the last 400 or 500 years in science. Science seems to move forward inexorably, and we're discovering new things all the time. That is tremendously important, and it's one of the most remarkable things about science. But to extrapolate that and to say that science will eventually understand everything is to set aside the fundamental points that I've tried to put forward, which are that if indeed there are phenomena in the world which don't possess the reproducibility and the clarity which science insists upon, there is no hope that science per se can eventually describe those, because it's impotent to do so. And in fact, the only way that we could argue that science will somehow explain those things is to change what we mean by science. So the bottom line is, it's a good point, and my focus on reproducibility and clarity and trying to explain what I mean by natural science is aimed at establishing that there are things in the world that are inherently unscientific by what we mean by science today. And so what we mean by science today cannot reach the point of describing beauty or justice or those kinds of things, because those things are all to do with other things that science has set aside. They're often to do with purpose, people, and their concepts which lack this clarity. So that's my answer to that question. Another question.
Other questions? Well, Mike will make its way over. While keep your hand up so we can find you. Dr. Hutchinson, if I could ask, while he's heading over there, with the beauty example, I mean, even if you could come up with a scientific account for beauty like you did the symbol clash, something about aesthetics or how color combinations affect chemical processes in our body, it would still be a complementary account to them.
Exactly.
Is that what it would?
Exactly.
It wouldn't, even if you could explain it, it wouldn't be the only explanation, I think. So.
Yeah.
In Luke 2:52, we're told that Jesus grew in wisdom and stature and favor with God and man. And inherent in that, I see 6 ways in which Jesus set an example for the 6 ways in which we grow in intellect, in emotional, in physical, in moral, in social, and in spiritual ways. Abraham Maslow's hierarchy listed 5 of those. And in the post-World War II ways in which all institutions incorporated Maslow's hierarchy to set policy and in education and military and all of our institutional policy making, we incorporated 5 of those and we lopped off the spiritual. And even though Maslow included peak transcendental spiritual experiences, our institutional policy making did not, okay? But it is an important part of our growth and human development.
What's the question?
The question is, we have relegated religion to non-public policy, and it's obvious now that we take it out of the public square, and we don't want it to be in the public square, religion, because it's so volatile and it's can't be it's too
Too controversial.
Too controversial and too subject to so many interpretations, unlike all of the other ways which can be quantified and measured and set into policy stone stuff and measured. So yes, we do relegate it. We take it out of the public square, and yes, it is relegated.
Is there a question?
You got to ask a question. You haven't asked the question yet.
The question is, or I guess the comment is, that's what's happened.
Okay. Well, thank you.
So how do
I think there's some. Okay, let me
bring it
respond.
back into the public square?
Yeah, let me respond. I think there's some truth in what you say. I think there is a sense in which, from our political and social discussion, there has been a setting aside of religious perspectives. I think in the U.S., actually, that is not always the case. More so, I think that we've remained in the U.S. a country where religion has a voice in a way that is perhaps greater than in some other European and Western nations. I do think that I should probably say as little as possible about politics, because I'm not a student of politics per se, but I agree with you. I think that very often this has been put aside because of scientism, because you can't measure religion. But I would like to say that you also can't measure lots of other things, and many of the issues that we discuss in politics are addressed in ways where we set aside some of the spiritual principles, but also some of the human principles, because we take polls or we, try to reduce these societal questions to numbers all the time. And that's part of the influence of scientism on some of these other disciplines. That's about as much as I'm going to say about that one.
Right here.
I'm thinking of a Christian scientific apologist, somebody like John Lennox, who often uses the analogy of if you see a menu or language, there's a mind behind the language. And he often refers to DNA as an example of language or a mind. He sees a mind in DNA. And so there's a lot of discussion about how do you interpret what appears to be design in nature? So I wanted your thoughts on that.
Thank you. So there's a question about design. I think everyone heard it. Here's what I think about design. First of all, I think every Christian worthy the name believes in intelligent design, little I, little d, in the sense that God designed the world, the universe, and God is intelligent, okay? So as far as little I, little d, intelligent design is concerned, I think we all believe it. I certainly believe that the universe is the way that it is because God wanted it to be that way, designed it, planned it that way, and made it that way. That's one question. But there has been, for the last 60 or more years, a big argument about a movement, which I call capital I, capital D, that calls itself the intelligent design movement. And the important aspects of this movement which are that it's an attempt to revive, in a certain sense, the philosophical argument for design, which was very, very important in the 19th century in Christian circles. The notion was that we could perceive in the world around us, in nature around us, things which we could definitely identify as being design. And this was particularly applied to the biological world. The exquisite adaptation of animals to their environments and those kinds of things were regarded as obvious evidence of design. The reason why Darwin's Origin of Species was such a controversial book when it first came out was precisely because the church had put a great deal of intellectual capital into the argument from design. These days, evolution, in the biological sense of natural selection and common descent, which are the two key pillars of evolution, is extremely well established scientifically, far better than it was when Darwin published his book. The evidence has been mounting over the 150 years since Darwin, and in the last 30 years with the explosion of our understanding of genomics, we now, I think, are in a position where to argue about common descent, at least in generic terms, is to ignore the science we know. So we have this situation that the church put a lot of intellectual stock in intelligent design in the 19th century, and went through all kinds of conniptions and arguments which are still with us today about evolution precisely because of that. So I approach this whole question of intelligent design much more cautiously. First thing is, I'm not going to base my faith on my ability to prove that there is design in nature. I think it's very difficult to prove that there is design in nature. Indeed, I think it's impossible to prove scientifically that there is design, because science sets aside purpose, it sets aside agency, as part of its principles. And so scientific descriptions, by their nature, are aimed at having non-intelligent explanations in a certain sense. But I do think that there are in science, nevertheless, some things which very strongly suggest to me that there is a designer whom I take to be the living God. I think that there are certain arguments which I think we need to be more modest about than people were, in the 19th century, or that William Paley was, for example, in his famous book about natural theology. But I still think that there are many things which point us in that direction, and one of them is fine-tuning. That is, the idea that the laws of nature, if they were slightly different, if some of the constants of the laws of nature was just a tiny bit different, the world would be so different, and probably there wouldn't be the complexity of the biological species that we see around us, and probably we wouldn't exist and intelligence wouldn't exist. That is, to me, an interesting, fascinating question. Why, therefore, is the world the way it is? And physicists today say they don't know. And that basically, as far as they can tell, the world didn't have to be this way. It could have been elsewhere, otherwise. And those who are, like me, people of faith, are very happy saying it's because God designed it that way. But there are plenty of other people who prefer other answers, which I won't go into. Thank you.
Other questions? We've got some time. Chuck, right back here. Flip. Keep your hand up so our microphone can find you.
Are there different forms of scientism, like different degrees? Oftentimes I see that believers in scientism will sort of implicitly or maybe explicitly give philosophy or specifically logic a pass as another route to knowledge.
That's a good question. I do think that I think most people recognize that, for example, basic logic is not very obviously something that you find out empirically, so it can't be discovered by, what we think of as being the methods of natural sciences. And mathematics is in that sense very mysterious. I mean, many secular scientists will agree with the idea that, Einstein put it very pithily, is that the most, I can't remember the quote exactly now, but the most unintelligible thing about the world, it goes something like, the most unintelligible thing about the world is that it is intelligible, okay? But it's his way of saying, it's remarkable that mathematics, which as far as we know is simply an invention of our minds, okay, describes the world as well as it does. And I think that's another, by the way, this is another example of something which leads me to suppose that the idea of there being a creator, personal, relational creator God is a very good explanation for why that is, whereas secularists have little explanation for it. So I'm not sure whether I'm addressing quite your question, but of course, there are all kinds of shades of scientism in our world today. There are all kinds of beliefs about it. I've talked about scientism for probably 15 years in lots of different kinds of audiences, and the responses rest, to cover the entire spectrum. Some people will say, well, of course scientism is true, okay? Yes, it's the case that the only thing we really can trust in terms of knowledge is what we discover by science. And then at the other end of the spectrum, there are people who said, I don't think anyone believes that. So that scientism is a straw man you're putting forward, okay? So there's a whole spectrum of beliefs about it. The crucial thing about scientism is that it's very rarely brought out into the open and talked about. Because what happens is it goes on in the background of people's thinking. And that's one of the reasons why I try to bring it out into the open, because unless you bring it out into the open, it's hard to make a distinction between the things which are a result of investing in scientism as opposed to the things that are really, truly science. Thanks for that question.
Others? He's coming up behind you.
Uh, for Aristotle, God was the creator. He was the God, the creator of the universe. And he was one of the first astronomers, I guess, and one of the first scientists, probably. But he wrestled with the question that our children ask us, you know, and that is, what was the beginning? Who created the beginning, you know?
Yeah, and Aristotle was obviously a very important, influential Greek philosopher, and his the rediscovery of Aristotle's writings towards the end of the Middle Ages was a very important part of the intellectual development, and for a long time, Aristotle's writings were the authority in science for the Western world, and they were adopted by the church, and they became kind of enshrined in Western and Roman church thinking. Actually, the scientific revolution, which I sort of alluded to, which took place in approximately, the 17th century, was in many ways a repudiation of Aristotelian science. Aristotle was a pretty good scientist, actually, in the sense that he really studied nature. I mean, he wasn't just an armchair philosophizer, but he had all kinds of concepts about how the world worked, and he had various, he had 4 different ways in which causation worked. And in particular, he advocated, for example, that bodies fall because they have an inherent sort of downness to them, and they have an inherent principle of falling. So actually, what really liberated natural science was setting aside some of those ideas of Aristotle and focusing instead of causality in terms of final causes, to settling instead on efficient causes that were acted directly. For example, the ideal in the scientific revolution was that we would have mechanical causes of things. We would describe things in terms of things pushing one another and so forth. We don't do that in science right now. Science has become much more abstract than the intentions of the scientific revolution were. But so yes, Aristotle was a very important person in the history of science, and he was a theist, as you were pointing out, in part because he had wanted an answer to why is there anything? Why is there stuff at all? This is another of the philosophical arguments concerning theism in general. So thank you for that point.
Right here. Let me do this one, and then we'll come back to that side of the room.
Thank you very much for your discussion this evening. I had a question largely related to the idea of beauty being interpreted with the rise of machine learning, the rise of artificial intelligence. What are your thoughts on that with respect to will the machines, will there ever be consciousness?
Okay, artificial intelligence. Will computers ever be conscious? I don't know the answer. I don't fear it. I do think there are lots of dangers associated with it, but I don't fear it in any kind of fundamental sense. I don't think that if we reach the point where there was some kind of AI that, to all intents and purposes, was conscious, that this would somehow prove that there is no God, or it would show that Christianity is false or something like that. I don't think that would be the case. I do think it would make us nervous, and as I say, I think there would be dangers associated with it. But I think that we're so far from that, it's a bit speculative. I mean, AI these days is very different from consciousness. So we have round about us, an amazing amount of AI. You can pull this out and say, okay, Google, what's so-and-so? That's amazing. I mean, I can see by the gray heads around this room that there are plenty of you here who couldn't have dreamed of that, like me, who couldn't have dreamed of that when you were young. So I think that there is, in a certain sense, some success about AI and machine learning and things like that. But it's very different from consciousness at the moment. And so HAL 900 is still a long way away.
we wait with interest then.
Yeah.
I'd like to hear you comment on the authenticity, the authority, the inspiration of Scripture, and how that relates to this scientism.
Yeah. Okay. My own viewpoint, this is a theological viewpoint, not a scientific viewpoint, is I approach the Scriptures in accordance with what I take to be its nature as described in 2 Timothy 3:16. All Scripture is inspired by God and profitable for teaching, reproof, and correction. So that's my personal view. Of course, the Christian church has lots of varied views about how we should approach Scripture. I'm going to talk a little bit about the relationship between science and the Bible tomorrow, so come tomorrow. But just quickly, I think it's very important to recognize that the purpose of the Bible is for teaching, reproof, and correction, and it's for training in righteousness. It isn't so that we can be good scientists. And so I think it's a mistake to go to the Bible and look for science there. And I think that that's actually one of the important things that we learned in the scientific revolution. In fact, that was one of the big changes that took place when modern science got going. We didn't, in the end, rely upon the Scriptures and some kind of strained interpretation of them, of the Scriptures, to tell us, what happens in the natural world. We recognized that actually the natural world, if it's a creation of God, speaks for itself. And I think that's what we do. I don't think that those two things are in conflict, and I think we should be very careful not to put them in conflict.
I wonder if I could say, let me say briefly as a follow-up to that, in organizing this event, as Dr. Hutchinson and Dr. Majami and I had some conversation, I think one of the values was that we agree on our authorities. We had extensive conversation about kind of where we are on things, and it's difficult to have fruitful conversation when you don't agree on the authorities. And so we wanted to have fruitful conversation, and that was part of our discussion. We do take the Bible to have an authoritative and trustworthy role in our lives. And since we agree on that, we're in a better position to consider how science relates to it.
Yeah.
So one more question, I think, and then we'll look to the rest of the room.
I just want to know why it's called a crab nebula.
I actually don't know offhand why it's called the Crab Nebula. Does anyone know? Yes, yeah, ask Google. Okay.
Sure, yeah. I mean, if you all are engaged, we're happy to have the conversation.
Yeah.
So,
Yeah.
right here.
No problem.
I've got this. Okay.
Thank you. Thanks again. Very fascinating discussion. Chesterton said that it's an act of faith believing that our reason has any bearing on reality whatsoever. Some theologians have said that at the time of the fall, which gave us original sin, that not just the creation was corrupted, but our thinking was corrupted too. And so they say we must rely on special revelation, i.e. the Bible. My question is, we have to use our own intellect to interpret the Bible. How do you balance those two things?
Okay, yeah, that's a deep theological question. It's not a scientific question, and I think I'm going to punt on that one because we have a seriously trained theologian in the room, and I don't want to. And there's another one at the back. Where is Hans? I don't want to tread on their. I'd be happy to take it offline. Okay.
Say the question one more time. How do
you balance the two? I mean, the intellect that we must use, God expects us to use our brains, with the notion that even our thinking has been corrupted to some degree in science and theology, whatever.
I think if I say briefly, I think it's important to cultivate some humility with regard to our intellects. And in some ways, our methodologies are aimed at helping us with that. If you study theology, there's some pretty extensive work you do before you even get into the discussion to say, here's how we're going to have this discussion. Here's a method we'll employ. And that's aimed at helping us not think too much of our arguments sometimes, I think. So there's if we can cultivate some humility, if we can stand in front of a room of people and say, I don't know, still thinking about that one, I'd like to think about it a bit more, then that's a good place to start anyway.
But I will say one last thing on that, and I'm going to preach on Genesis on Sunday, so we'll hear about it, okay?
On that question, I was just gonna, one way that question actually overlaps with, Ian, what you've shared with us is that, the historian Peter Harrison out of Australia actually is an interesting book. I think it's The Fall and the Foundation of Science or something to that effect. But basically what he says is that in the 17th century, when you had the early scientists who were called natural philosophers, they all believed that the fall had affected our intellect. And interestingly, because they firmly believed that Adam had sinned, and so our minds don't work very well, they said, we can't trust our minds, we can't be armchair philosophers, so we need to go out into the world and investigate it empirically. And so Harrison's argument is that modern science arose because of belief in the doctrine of the fall of Adam and Eve. So I think that's kind of interesting in line with what you've said.
Thank you.
Others? Yeah, Chuck, go for it.
Second bite at this cherry, right?
Thanks.
A different cherry, maybe.
So it seemed like a lot of your examples of things that science can't explain, even under scientism, were beauty. So like sunsets and the love of a woman and music. Are there, I feel, maybe it's because I'm a millennial, but I constantly have to fight this within myself, the belief that beauty is in the eye of the beholder. It's completely subjective. Are there, I don't know, like things you've run into, books you've read, or people you've encountered who've given like specific strategies for convincing people that beauty is actually objective, beyond just pointing to things like a gorgeous cathedral or something like that?
Well, I think the most persuasive topic that addresses this is the question of justice. I mean, maybe you could argue beauty is in the eye of the beholder, and we'll measure beauty by, taking a poll of everybody who goes to see, a famous painting, the Mona Lisa or something, and if a high proportion say it's beautiful, then it's beautiful. Okay, so that's a scientific view of beauty. Okay, I think very few people are comfortable doing that with justice. Okay, and I think part of that comes back to the comment that was made here about us having dispensed with the spiritual out of our society. When we dispense with the spiritual, we're left, as Nietzsche understood, with essentially a nihilistic view. It's a reductionistic, nihilistic view. Nothing really matters. But essentially nobody is willing to take, I think almost nobody is willing to take the view that there is no such thing as justice or injustice, okay? So some principles of ethical belief in our society are still honored, even though there isn't much philosophical underpinning to them. And that's why you millennials, have a struggle, because you've grown up in a society where we've set aside the foundational principles that those of us who have theological backing for our ethics feel is an easy ask. So it's much more natural for people that are over 65, let's say, to think in terms of there being foundational ethics than it is for people who are sort of under 40. in part because of what's happened in our society that was alluded to earlier. I think that what that means for us Christians is that we have to have a clear understanding of where the foundational principles in our lives come from. So maybe this isn't a very good intellectually persuasive philosophical argument for God, but I do think it's a tremendously important and attractive part of our faith, that we have foundational beliefs that we concerning love and concerning justice and concerning beauty and so forth. And our lives for that are so much richer because of that. And so maybe that's not a philosophical way to argue someone into the kingdom, but maybe most people aren't argued into the kingdom anyway. They are perhaps drawn by love and by beauty and by justice.
In the back.
I feel like that one of the biggest holdups for Christians is, and I don't know if you would call it the science or scientism of the age of the earth versus a true creation. And I realize that the Bible is not a scientific textbook. It doesn't tell us exactly everything, but it clearly states that there was dark and light on the first day, and that was the first day, and there was a 7-day creation, apparently, according to what it says in Genesis. Do you think, and I think there are ways to even use the scriptures to prove that the age of the earth or the universe could be much older than that? And it gets very complicated, because when you get into Ezekiel, there are scriptures about Satan ruled the world for a time. You get in the New Testament, Christ himself, our Lord and Savior, says he saw him fall out of heaven. And it also says that the world became null and void. In other places in the Old Testament, it says God created nothing out of havoc, and that would lead you to believe that it was created perfectly. Where are you on the age of the earth when science tells us it's billions of years old, but if you do the math according to the scripture, we're only 8,000 years old.
No, 6,000. 4004 BC was what Archbishop Usher came up with. Yeah, okay, thank you for that question. Let me start by talking about the science for a moment. Essentially, everything in the physical sciences supports the now commonplace understanding that the universe is very old, the Earth is very old. The universe is 13.8 approximately billion years old. The Earth is over 4 billion years old, and it's really not controversial in the least in the sciences. Science knows this, it's not just that there's one or two things which show this. Everything in science sort of builds up that case. So there we've got the scientific view. What's the biblical view? Well, I think the biblical view needs to be thought about rather carefully. I don't have time to expand too much on this. Again, I'm going to preach on early chapters of Genesis on Sunday, so if you're there, we'll talk about a particular aspect of this, but it won't be the age of the universe. So let me give you a little bit about the age of the universe, okay? I think it's tremendously important to understand the kind of literature there is in the Bible. There are lots of different types of literature in the Bible. And understanding what type of literature the first few chapters of Genesis is helps us enormously in understanding what it means for us. And I insist that you do not find scientific literature in the Bible. And it's a mistake, therefore, to try to interpret the Bible in a modern scientific sense. What the first chapter of Genesis, and you alluded to it just a moment ago, the message of the first what is the message of the first chapter of Genesis? Who wants to tell me what the most important message of the first chapter of Genesis is? Okay, everyone has their own idea. Here's what I think the most important message of the first chapter of Genesis is. It is that God made it, the universe. And it's not about how did God make it, it's that he made it. And why is that? Because the Hebrews, were surrounded by all kinds of tribes that had their own tribal deities, each of which was fighting for their tribe against the other tribes. And the most important message in Genesis is to tell those people, the Hebrews, and us for that matter, that no, God is not a tribal deity, that if God is God, God created everything. That God created everything, and that he is the God of everything. And that's, in my view, the most important message in Genesis 1. Now, the extent to which the details of the story should be interpreted as historical is something I'm going to leave to the Old Testament scholars. But I still insist that's the most important message. I had the most fascinating experience. I went to Australia in 2016, and I was a visiting professor at a boys' high school in Sydney. It was a Presbyterian high school in Sydney. They were trying to recapture some of their Christian roots, and one of the ways they were doing this was by inviting Christian scholars to be there. And I and an Old Testament scholar, actually from Vancouver, from Regent's College, were part of a panel that was in front of 200 high schoolers. That was the most terrifying audience I've ever been. You're very calm by comparison. And the first question was about the literal interpretation of Genesis, okay? And I said, well, look, I'm the scientist. He's the Old Testament scholar. Okay, so I punted. Okay, and what did he say? He said, it all depends what you mean by literal. Do you mean literal to them or literal to us? Because what literal means is very different today. Because we all think in scientific categories. We all think in terms of galaxies and geology and so on and so forth. They didn't think about it in that way. It's completely different. So he fudged on that one, so I'm going to fudge on it too.